Hi, this video will go over how to balance a redox reaction. So as I mentioned in the previous video, the steps to balancing a redox reaction are different and a little more complicated than to balance a regular reaction. So I'm going to go through an example with the following reaction. So MnO4 minus plus C2O4 2 minus yields manganese 2 plus CO2. So that's our reaction. The first step is to determine which species is oxidized and which is reduced. We're going to use the same steps that we went over in the last video. So first, the two reactants. MnO4 minus. Okay, so oxygen is -2. It's always -2. Unless in a peroxide. Right, that's a general rule. So, the manganese then, it's going to have to equal +7. Because we have 4 oxygens with -2, so that gives us -8 overall, plus whatever our oxidation number for manganese, and it has to equal -1, because that's the overall charge of the compound. So -8 plus 7 gives you -1. So next up is going to be the C2O4 2 minus. So again, oxygen is going to be -2. Then the carbon is going to equal +3. We know it's +3 because, again, we have -8 due to the oxygen, plus 2 times whatever the oxidation number of carbon is, since there's 2 of them, and that's going to equal -2 overall. So then I get 2x is equal to 6, so x is equal to 3. Then my manganese 2 plus, it's just +2. And then for CO2, the oxygen is -2, meaning the carbon is going to be +4. Because overall it's a neutral charge, 2 oxygens at -2, so the equation would be -4 plus x equals 0, so then x would be +4. So we figured out what is reduced and what is oxidized. So step 2 then is going to be to divide into the half reactions. So first, the reduction half reaction. It's going to be MnO4 minus plus 5 electrons to give me Mn2 plus. And I know it's 5 electrons because I'm going from +7 to +2. Then our oxidation half reaction is C2O4 2 minus is giving me CO2 plus 2 electrons. It's 2 electrons because there are, right when you balance that, that's 2 CO2s. So each of the carbons is going from +3 to +4, so that's 2 electrons. But the balancing isn't critical here, because we're going to balance each of these half reactions with the next step. And even the number of electrons in this step isn't critical to know, because we'll be able to solve that once we balance in the third step. So step 3 now is going to be balance each half reaction. And this is where it gets a little bit different than usual. So I'm going to start with the reduction half reaction. It's MnO4 minus is giving me Mn2 plus. And I'm not writing the states in here because I might run out of room if I have to start doing that. And I don't want to run out of room. So step 1 is going to be to balance the non-hydrogen or oxygen atoms. We have 1 manganese on the left, 1 manganese on the right, so we're fine. Step 2, to balance any oxygens we add water. So we have 4 oxygens on the right, or on the left, and none on the right, so we add in 4 waters. But now we have to balance the hydrogens, because I've put hydrogens in now. So we have 8 hydrogens on the right and none on the left. So I'm going to add in 8 hydrogens to the left. So now all my atoms are balanced. My final step is going to be to balance the charge on both sides. My overall charge on the left is +7. My overall charge on the right is +2. So I have to add in 5 electrons to the left side. So there we go. That is my oxidation or my reduction half reaction. And the other way you can confirm is the reduction one is my electrons are on the left. Right? The electrons will always be on the left for the reduction half reaction. They'll always be on the right for the oxidation half reaction. All right, I'm going to switch colors now. Now we're going to do the oxidation half reaction. So C2O4, 2 minus, is going to give me CO2. So first step, I have to balance the carbons, because they're a non-hydrogen or oxygen atom. So I have 2 carbons. Step 2, balance the number of oxygens. Both sides right now have 4 oxygens, so we're fine. And neither side has any hydrogens, so I don't have to balance that either. So that means the last step I have to do is just to balance the charge. I have a 2 minus charge on the left with the reactants, 0 charge on the right, so I have to add in 2 electrons. So now both half reactions are balanced. Next step is I have to combine the 2 reactions, because I divide them into half reactions and then I have to combine them together into the net reaction. The rule with combining these is I have to get rid of the electrons. In order to do that, I have 5 electrons right now on the reactant side in the reduction half reaction. I only have 2 electrons as products in the oxidation half reaction. To balance that out, I have to multiply the oxidation half reaction by 5 and the reduction half reaction by 2, because that will give me 10 electrons on each of the sides. So I'm going to multiply them and then add the 2 reactions together. So now, from the reduction half reaction, I have 10 electrons plus 8 hydrogens, plus 16 hydrogens, right, because I doubled it, plus 2 MnO4 minus, and then from the oxidation, plus 2 C2O4 2 minus. This will give me 5 C2O4 2 minus, right? Because I multiplied the oxidation one by 5. Right? This is where you have to really be careful, because you're multiplying the 2 by different numbers, so you have to make sure you're accounting for that when you're adding them together. Right? So you have to be careful. I'm going to have 10 CO2s plus 10 electrons, then plus 2 manganese 2 plus 8 H2O, Ooh, so I barely fit it in. I cross out the things in common, so our 10 electrons on both sides are in common. But that's it. Otherwise, there's no other things we have in common on both sides. So our final answer is 16H plus 2 MnO4 minus plus 5 C2O4 2 minus to give 10 CO2 plus 2 Mn2 plus 8 H2O. That is our balanced reaction. So more complicated than a normal reaction is to balance. So I'm going to go over one other example, because this reaction was in acidic conditions. We have H plus as a reactant or a product, right? So that means we're in acidic conditions. But what if we're in basic conditions? So the next reaction is going to be Cr2O7 2 minus plus Cl minus to give chromium 3 plus Cl2. And we're in basic conditions. Step 1, figure out what's being oxidized and what's being reduced. So for my Cr2O7 2 minus, oxygen again is -2. So chromium is going to be -14, because we have 7 oxygens at -2, plus 2x is equal to -2, the overall charge of it. So that means x is going to equal +6. So then for my chromium 3 plus, the chromium is equal to +3. Then chloride's easy, Cl minus, the chloride is equal to -1, because that's the overall charge. And then for Cl2, my chloride is equal to 0, because it's an elemental form. So my chromium is being reduced and my chloride is being oxidized. So next step, write out the reduction half reaction. So my reduction half reaction is Cr2O7 2 minus gives me Cr3 plus. And I'm not including the electrons yet, because we're going to go ahead and balance this right now and figure out how many electrons we have. We should get 6, right? Because we have 2 chromiums at +6 are going to 2 chromiums at +3. So we should get 6 electrons when we balance here. So first step, balance the non-oxygen or hydrogen atoms. So we have 2 chromiums on the left, 1 on the right, so I'm going to have 2. Now I need to balance the oxygens. We have 7 on the left, none on the right, so we're going to have 7 H2O. Then to balance the hydrogens, we have to put in 14 H plus on the left, because we have 14 on the right. So now to balance the charge, our charge on the left is +12. 14 times +1 -2, so +12. On the right, it's +6, so we're going to have 6 electrons. So remember, I said when we're in basic conditions, we're going to have to do things differently. Not yet. Everything so far, we're doing the same. Okay, so now the oxidation half reaction. Cl minus to Cl2. So first thing I need to do, balance it. So I have 2 chlorides on the left and now 2 on the right. There's no oxygens or hydrogens here. The only thing I have left to do is balance charge. My charge is -2 on the left, 0 on the right, so plus 2 electrons. I'm not going to have to multiply the top reaction by anything. I just need to multiply the oxidation one by 3, so that way I can balance out the number of electrons. So now I'll add these together, and I'll get 6 electrons plus 14 H plus Cr2O7 2 minus plus 6 Cl minus gives me 3 Cl2 plus 6 electrons plus 2 Cr3 plus 7 H2O. So now I can cross out my electrons. I'll rewrite it as one reaction now using a new color. So my combined one now, 14H plus Cr2O7 2 minus plus 6 Cl minus to give 3 Cl2 plus 2 Cr3 plus 7 H2O. But if we're in basic conditions, I can't have any hydrogens left, no H pluses. So to get rid of the H plus, I have to add hydroxide in. But I have to add the same amount of hydroxide to both sides. So to neutralize the H plus, I have to add in 14 hydroxide. So I'm going to say plus 14 OH minus, meaning over here I have to add in 14 as well. So now add that together, and I'll get 14 OH minus. The OH minus over here reacts with the H plus, so it's actually going to be 14 H2O plus Cr2O7 plus 6 Cl minus to give me 3 Cl2 plus 2 Cr3 plus 7 H2O plus 14 OH minus. I can cross out anything I have in common, so I can take away 7 of the waters, and that becomes 7. Nothing else in common. So my final answer is going to be 7 water plus Cr2O7 2 minus plus 6 Cl minus to give 3 Cl2 plus 2 Cr3 plus 14 OH minus. So that's how you balance in basic conditions. You follow all the same steps until the end, and then you add the hydroxide. Remember, you have to add the hydroxide to both sides of the reaction, though. That's one of the most common mistakes in balancing redox reactions, is adding the hydroxide to both sides. Another common mistake, when you multiply a reaction, like right here, sometimes people will multiply the side that has the electrons and forget to multiply the other side too. So sometimes people might say, get 3 Cl2 plus 6 electrons, but still only have 2 Cl minus. Nope, you got to multiply everything by 3. So that's the reason I put the entire reaction in parentheses times 3. Then ultimately at the end, you can check your answer by making sure you have the same number of atoms on both sides. So I've got 14 hydrogens on the left, 14 on the right. I have 14 oxygens on the left, and I have 14 on the right. 2 chromiums on the left, 2 chromiums on the right, 6 chlorides on the left, 6 chlorides on the right. So I'm balanced completely correctly, and I know my answer's right. So that's a benefit of balancing redox reactions, is you know if you get the correct answer at the end.